Here you're being asked to prove that if all f's are g's, then it follows that if everything is an f, then everything is a g. The first thing to notice about this argument is the main operator of the conclusion. We've got a conditional here. This indicates that CP is going to be productive. Now, according to rule CP, in a subproof, given the assumption of some sentence, let's call it P, if we can validly derive another sentence, let's call it Q, then what rule CP allows us to do is to derive the conditional where our antecedent was our assumption and our consequent is the last line of our subproof. And even though we're now working in PL instead of TL, CP works the same way. We'll assume our antecedent and we'll try to derive our consequent and end the proof with CP. So that means line 2 is the antecedent of the conditional that we want, and we indent to indicate that we are in a subproof situation. Now when you take a look at lines 1 and 2, do not be tempted to apply modus ponens to try to get something like this. There are two big problems here with using modus ponens right away. The first problem is that line 1 is not a conditional. It is a universal generalization, and if it's not a conditional, we can't use modus ponens. Secondly, modus ponens requires that we have an exact match of the antecedent, but line 2 is not an exact match for our antecedent. Instead, and typically, when you have universal generalizations, instantiate them. Once you've got instances, you're more likely to be able to use other rules. So here, let's start with line 1. To use UI correctly on line 1, we need to remove the quantifier and write down the rest of the formula, replacing any occurrence of the variable that was universally generalized with the same constant. We'll use UI on line 2 as well. Again, we'll remove quantifier and we'll write down the formula replacing any occurrence of the variable that occurred within the universal quantifier with a constant. And now in lines 3 and 4 we do have the correct ingredients for modus ponens. And more importantly, we have an instance of our desired consequent. Now to get our desired consequent, we're going to have to use UG on line 5. UG is one of the rules that has a couple of restrictions. The first restriction states that the constant that's generalized upon doesn't occur in any of the premises. A doesn't appear in any of the premises, so we're okay there. The second restriction says that the constant can't have been introduced by EI. We don't use EI in this proof, and so we're safe there too. And finally, the constant can't appear in any assumed premise that hasn't already been discharged. That is to say, that is still part of an open subproof. And here you may be thinking that we are in danger of violating that restriction because we are still in a subproof. However, the place that you need to check for that restriction is just in the line of the assumption. And since A doesn't occur in that line, we're safe there too. And so at line 6, we do have a correct use of UG. And now we're ready to close our subproof. We write over our assumption, turn that into an antecedent by writing a horseshoe, and then copy over the last line of our subproof to take as our consequent, and we cite conditional proof and the entire subproof. And there you have it, a straightforward example of conditional proof in the predicate logic.